So this presentation is mostly a recap of my licentiate presentation on data-driven decision support systems for product development, which is a data exploration study using machine learning. So I'm gonna just go briefly about. So these days, the complexity of engineering systems is increasing mainly due to the technological advancement to fulfill the product functionality and also to transition towards product service systems. So here so thereby bringing in the cross-functional design teams in the design process. Complexity is generally associated with a number of technologies, subsystems, and components. To deal with complexity, the common approach is to make the complex form, to transform the complex form into a manageable form by making use of modeling and simulations. And also, product development is an iterative decision-making process, which is characterized by uncertainty and ambiguity, where uncertainty is lack of knowledge, thereby necessitates the need for methods and tools to support the complex decision-making process. At the early stages of product development process, there many decisions can be made. So to make use of those decisions, understanding the decisions made at this stage can have a good value, both from a user and a provider perspective. So a major first in the process is the search for information and subsequent build of knowledge. So how do we transform the data into information and knowledge? To do that, we make use of machine learning concept integrated into product development. Basically, machine learning can be defined as a practice of using algorithms to parse data in order to make predictions. The idea here is to teach and train computers by feeding them with data and defining the features. There are many different machine learning algorithms, as you can see here, but my research I mainly used three main machine learning techniques: regression, artificial neural networks, and natural language processing. By making use of the machine learning concept, I tried to answer the research question: how machine learning techniques augment the decision making capability in the conceptual stage of product development. To solve this, I have an opportunity to work with two research cases. One is with the heavy construction machines for the design exploration study of complex systems. And second one is about e-health. Coming to case study one, in a simulation-driven data exploration studies, it is generally classified as a two-level hierarchies with independent variables at the bottom level and dependent variables at the top level. However, these independent variables might not be associated with the design attributes. Rather, a subset of design variables and its associated constants or parameters drive the configuration of a particular component or subsystem or also its attributes. So these tends to give a virtual intermediate level. However, the data for this intermediate level doesn't exist, or to analyze it doesn't exist. So we use machine learning concepts to populate the data and analyze the data. Case study 2 is more about e-health, where there is a proven evidence that people suffering from mild dementia or mild cognitive impairments have a more chances of oral not having a good oral hygiene. Thereby, but with the advancement of technologies, electric toothbrushes have the possibility to collect the data of their brushing instances. But this has certain limitations where the individual needs to transfer the data from the mobile, from the toothbrushes to the mobile applications. To solve this problem, the single core processor can be used, which can automatically transfer the data from the toothbrushes to the local storage computers, and thereby the oral decision makers can visualize the data and take the necessary decisions. The entire research process is divided into three aspects: data augmentation, data analysis, and visualization. Data augmentation is nothing but the process of increasing the amount of data either by using the existing data or by synthesizing a new data. Here you can see the left-hand side, it's original data, and the right-hand side, it's a augmented data or synthesized data using machine learning concepts, and this provides the additional data for the decision makers, guiding them in the decision-making process. Data analysis is the process of converting the data into information and knowledge, where we can use the methods such as cause and effect relationships to understand the relationship between dependent and independent variables, and thereby make predictions from that thing. So that helps us to build trust with the decision makers, and thereby the decision makers can analyze or test their design choices and analyze their consequences of their design choices. Once we have this, it is important to communicate with the teams. So we use visualization techniques, for example, CAD model, where you can see the positive and negative impacts of the design choices, and the bar graphs. So by having visualization, it makes the data accessible and interpretable for the decision makers. Summarizing my entire answer, so here data analysis and data visualization has the capability for the decision support systems, and using machine learning technique, we can extract and associate data for sharing information, which increase the efficiency and effectiveness of the decision making process. And it also supports the cross-functional teams in sharing information. This is just an outline, but if you want to read more about them, then you can use the below link to go in detail, and you can also contact me for more information.